Good morning, students. Welcome to video lecture on electromagnetic waves and transmission lines. Subject code U18AC 403. Topic polarization of electromagnetic waves. Polarization of electromagnetic waves. It is defined as the direction of the electric field at a given point as a function of time. It is the direction of the electric field. Types of polarization: linear polarization, circular polarization, and elliptical polarization. The electric field is given by E is equal to EXAX plus EYAY plus EZAZ. Consider a plane wave traveling in positive Z direction. For a plane wave traveling in Z direction, there is no field component along the direction of propagation. The two field components are present. One is along X axis and another one is along Y axis. The field component present along X axis is the first term, and the field component along Y axis is second term, given in equation 1. In two situations, the electromagnetic wave is linearly polarized. In the situation, if the electric field is having either X component or Y component. In this situation, the electric field is linearly polarized. If the electric field is having only X component, then it is X polarized. And if the electric field is having only Y component, then it is Y polarized. In other situation is the electric field has both the components in such a way that the phase difference between them is pi y minus pi x is equal to the multiple of pi. In this situation also, the electromagnetic wave is linearly polarized. In two situations, the electromagnetic wave is linearly polarized. Circular polarization. In circular polarization, the electric field has both the components EXAX and EYAY. It is X component and it is Y component, and the components are in such a way that their magnitudes are equal and the phase difference between them is a multiple of pi by 2. Then the locus of the resultant electric field traces circle. And one more thing is the symbol plus indicates it is a left circular polarization, and minus indicates it is a right circular polarization. Uh, the sign is very important in classifying or in solving problems in gate examination. I repeat, plus symbol for left circular polarization and minus symbol for right circular polarization. In circular polarization, the tip of the electric field traces circle. The other type of polarization is elliptical polarization. In elliptical polarization, both the field components are present X component and Y component both are present in such a way that their magnitudes are not equal, and the phase difference between them is multiple of pi by 2. Then the locus of the resultant electric field traces ellipse. Once again, the middle symbol is very important. If it is plus symbol, then it is left elliptical polarization. If the middle symbol is minus, then it is right elliptical polarization. A very small difference between circular polarization and elliptical polarization is, in circular polarization the magnitudes are equal, but in case of elliptical polarization the magnitudes are not equal. In both the cases the electric field has two components, one is along x and the other is along y. You can observe the animated images of linear polarization, circular polarization and elliptical polarization. In circular polarization, you can observe the tip of the electric field traces circle. Here, the tip of the electric field traces circle, and in elliptical polarization, the tip of the electric field traces ellipse. Sample problem 1 in GATE 1998. AX and AY. The electric field has both the components along X and Y. The phase difference between them is 0. So it is linearly polarized. The phase difference between them is multiple of pi. Then it is linearly polarized. Sample problem 2 asked in GATE 2012. The electric field has two components. One is along y direction and other one is along z direction. The electromagnetic wave traveling in x direction, it implies e power minus j25x. The electromagnetic wave traveling in positive x direction, it has y component and z component. They are in such a way that a plus j a z. The phase difference between the two components is 90 degrees. Once again, they are equal in magnitude. We can conclude it is magnitudes are equal with 90 degrees phase. Circular polarization. Refer to the solution. With substituting suitable parameters, we get the frequency 1.2 gigahertz. The right option is A. It is left circular. For plus symbol, it is left circular polarization. For negative sign, it is right circular polarization. Here, the positive symbol indicates it is left circular polarization. Refer to one more problem asked in GATE 2005. The magnitudes are not equal with opposite in phase AX plus J4AY. The magnitudes are not equal with 90 degrees phase. Not equal 90 degrees phase means it is elliptical polarization, left-handed elliptical polarization. For plus sign, it is left elliptical polarization. Negative sign, right elliptical polarization. For elliptical polarization, we discussed the magnitudes are not equal and the phase difference between them is multiple of pi by 2. The two conditions are satisfied with positive sign, positive left elliptical polarization it is. One more sample problem asked in GATE 2005. From the general solutions, you can observe 10 sine omega t plus beta x implies the electromagnetic wave traveling in negative x direction, the omega is equal to, and beta value is 0.004. Substitute in phase velocity formula to get the value of phase velocity. You can observe the electromagnetic wave traveling in negative x axis. One more gate problem asked in 2003. It is to calculate phase velocity. Substitute the parameters omega and w to determine the phase velocity. You can utilize the general solution 10 cos omega t minus beta z. From the general solution, you can retrieve the values of omega 2 pi into 10 power 7 and beta minus beta z, that is equal to 0.1 pi minus beta z implies the electromagnetic wave traveling in positive z direction. To determine the phase velocity, you can substitute the values of omega and beta to determine the phase velocity. One more sample problem. Two more sample problems. One is asked in 1994 and another one is in 2006. Both are based on same concepts. Once refer to the problem and its solution. Thank you. We will meet with the next lecture.